last time we have discussed about one example of convolution, and today we will discuss more example of convolution. Right. So I'm going to share my screen with you. Today we try to solve two example. One example is almost similar as what we have already discussed in the last time. It's not too much deeper, but the second one would be different. So the first example in which I will give just a hint about how to calculate the example, and then swiftly we transfer to the next example. I think the screen is visible. Please confirm me.
Yes, visible.
Okay, fine. Okay, so last time we have discussed about the one graphical method of a two square wave signal, how to convolute the two square wave signal, in which we have produced a trapezoid kind of a waveform by convoluting two rectangular signal. Okay, so we have taken an example of one signal, say x of tau exists from 0 to 4 with the amplitude 1, h of tau exists from the 0 to 2 and with the amplitude 2. So this part we have discussed, and then we have the first operation is apply on h of tau is to shift them then with the time reversal. So we have produced h of minus tau signal, and then we change this value of shifting amount t, and every times when the overlapping region is created, we find the boundaries of overlapping region, lower bound and upper bound. We take the integration of these two signals, means this is the area covered by this region, this is the area covered by the overlapping region, and integration limits as the boundary of overlapping region, and then we convolute the we multiply the two signal x of tau and h of t minus tau, and then whatever the output is assigned to is given to the y of t assigned to the y of t. Then we shift the signal t further, and when this boundary of the overlapping regions are changed, we will consider the next region, and for this region also we will identify the lower and upper boundary of the signals, and we convolute these two signals and find the output. So similar way we will repeat this process till the two signals are completely non-overlapping, or there is no overlapping area exist between the signal x of tau and h of t minus tau. And if we combine those points, so finally we can produce the signals y of t, right? So it shows the y of t does exist from as a 2t function from 0 to t, and from 2 to 4 it exists as a constant value of 4. It holds the constant value of 4 from the value of t 2 to 4, and for the value of a time duration time t 4 to 6, it has the function of 12 minus 2t, and after t is equal to 6, no any signals of y of t does exist. So this part we have already covered. Now but here fortunately both the signal x of tau and h of t minus tau is basically starting from 0, right? And it is like as a win-win situation. But in some other cases it is not possible every time this x of tau is starting from 0 and h of tau is also starting from 0. There may be some possibility that the signal doesn't start from 0, in which what happens, in which how the convolution is basically start beginning point of convolution is actually changed or shifted. How is it shifted, that we will see in today's example. So we again take a example of a two rectangular function, but unlike to the examples what we have covered in the last lecture, where all the both the signals starting from 0, we take the examples when either x of tau or h of tau is not starting from 0, or it may be exist with some different duration. All right, so this example we'll take today, and one another examples we'll solve today is the convolution function between two different kind of a signal, like as a one signal is a rectangular signal and another signal is a triangular signal. So we will see this two example in today's session. So we take this example where we have been given uh, the, we have been given this one x of t, sorry, we have been given these two things. x of t. Rather than t, it is better that I write the tau. So that is x of tau is given, and this signal is given to exist. Sorry, I remove this. This signal does exist from -3 to +3. So let's assume the signal is produced from -3 to +3. And the amplitude of the signal is 1. This is 1. Now another signal which is h of this is the signal I saw by the red color, so you can identify clearly. This signal is h of tau signal, which hold from 0 to 3. Yeah, amplitude is deeper. So I just say this is the amplitude of 2, which hold from 0 to 3. Right, and this is tau. So you see here there are two signals are there. One signal is x of tau signal, and another signal is h of t or h of tau signal. And we need to find the convolution between these two signals. So it is given, find the convolution for above signal. For above signal. So what we will do first, we will rotate the signal h of tau. So if we rotate the signal h of tau, then here after rotating, this signal is basically rotate with respect to this y-axis, 0-axis, and then we have amplitude 2, and this signal is h of minus tau, where the shifting is not applied, so we are considering n is equal to 0, right? And this point is -3. This 3 is the point at earlier amplitude at the point 3 is now shifted to -3. So this is rotated version of h of tau. It is known as a h of minus tau. Now, if you see the signal, then if we try to overlap with x of tau, right, and so that is already overlap, right? This point is the point t. This point is known as a point t, and this point will be start after some time interval 3. So this point is known as a t minus 3. But we cannot directly overlap this x of h of tau with this. I will show you. We cannot directly overlap the signal. Let's say take a copy and then paste on this one. So we cannot directly overlap this signal, right? Why? The reason is that if we try to overlap the signal here directly, then there are sufficient amount of overlapping does already exist. So what is important, what is important is that we have to start with the first point. I mean, we have to start in such a way so that this point -3 from where the actually overlapping should exist, right? It should be starting from there. So if we directly try to overlapping, so there are significant portions of overlap is already start. Actually, we have to start with the beginning of overlapping where there is no overlapping, and then we start overlapping, and then gradually this signal h of minus tau move inside x of tau, right? H of minus tau gradually move inside x of tau. From that point, we have to start. So this is not a right point. So if such kind of a problems does exist, to then we need to shift the signal in the side. We need to shift the signal left side so that the overlapping we can start from a very beginning. So for that one, what we can do, how much point we need to start, because this x of tau is basically starting from -3, and this h of minus tau, the first portion is 0. So this point we need to shift at -3. Why? Because this x of tau is actually starting from -3. It means we are shifting the signal in opposite direction. So if we are shifting the signal right side, then n is positive, but here we are shifting the signal left side rather than right side. So this value of n is negative. And how much negative? So 3 points, because actually this point should be starting from -3. We want the overlapping starting from here, right? First. So that's why what we can do, this signal we will produce h of -3 minus tau. H of -3 minus tau means our signal, this signal is shifted to some point -3. Sorry, it's my mistake. It just first end it will be shifted to -3. So where would be the second end would hold? The second end would be hold of at -6. So that is of -6 to -3, right? That is of -6 to -3. And this signal is shifted left side, so that's why this value n is taken as a negative. The n is taken as a negative if we shift the signal from left side, but if we shift the signal from right side, then the value of n is positive. Now the remaining things are almost the same what we have covered so far. So we can say if my shifting n is less than -3, right? Means if you further shift the signal, so there is no overlapping does exist. So then there is no overlapping. There is no overlapping, and in that case, y of t is equal to 0. Right? This is considered as a reason number one, the first reason. Now we take the second reason. So for that second reason, we need to uh, pull back those both the signals in a lower side. So here we take the signal, we copy the signal here, and we put the signal here. Right. So this is my x of tau. Now the second signal we will pick up is this signal as x h of 3 minus tau. We pick up the signal. We pick up the signal. Sorry, we pick up the signal from here. And we put in the next page. I mean somewhere here. Right. So this is the signal. Now we place this signal above this. Right. So assume this signal is we write as a n minus tau. I mean, it's a continuous function of time, so we can say it is a t minus tau. This signal is t minus tau, and now we assume we are in the region where the t is larger. We are in the region 2 where the t is larger than -3. I mean, shifting is larger than -3, right? So with this, we shift the signal in this side. We shift the signal in this side. So what happens after this? If we put the signal over here, so we can say this portion is completely put here, right? It is somewhere here. It is somewhere here, right? Now, as we place this point here, so this point is known as a point T, and this point is known as a T minus 2. So here also same happens. This point is the t, and at this point happens the t minus 2. It means the first end, that means lower end of h t minus tau is inside the x of tau, and the upper end it is outside of this one. And if we find
Sir?
the old, yes,
t minus 3 नहीं आया.
sorry, t minus 3. Yeah, right. It's my mistake. Sorry, consider it. It's a t minus 3. T minus 3. This is also t minus 3, right? Okay, so now if we go inside and we will find the overlapping area. So this is the overlapping area, right? This is the overlapping area where both the things are present, both the signals are present. And this overlapping area is basically covered by this Tn minus 3. I mean, so this is the upper bound, and this T is the lower bound. This T is a lower bound. So now if we find the integration of y of t, then we can say this signal for this signal y of t is minus infinity to infinity, but minus infinity to infinity is basically limited with the lower bound. Lower bound is -3 and upper bound is t. So upper bound is t, and here we write x of tau and h of t minus tau d tau. Now we know that x of tau is 1 and this h of t minus tau. This one is h of t minus tau, right? This function is 2. So we can say that is integration is -3 to t, and here the function is 1 and here the function is 2. And we take this integration with respect to tau. So it is 2. So that is 2. And if we apply this limit -3 and t, so finally we will produce here as a 2 tau, and the limit which is applicable here is -3 and t. So that is the 2t minus 2 into 3. I mean 2 minus 3. right? So that we can say is a 6. So that becomes a 2t plus 6, or some way you can say is a 2 times of t plus 3. Both are valid, right? Both are valid. Okay, but this is how much I mean, so this at up to how much time this will exist. I mean, this region does exist. So this lower boundary is when the shifting is larger than -3. So the first one will goes inside of x of tau. The first end of h of t minus tau goes inside x of tau. Now if you move further and further, if we move here further and further, so the first end will remain inside this x of tau till this one, when till it doesn't reach to 3, right? Okay, but now what's about the t minus 3? Whenever we move the 3 points, this t minus 3 is just 3 points far away from t. So it means whenever the t will reach somewhere here, and then t minus 3 is less than, this region does persist when the t minus 3 is less than -3, right? If t minus 3 is greater than -3, then second end will goes inside, and then overlapping region it will be changed. So that we say t minus 3 is less than -3 means that t is, if you shift this side, so t is less than equal to 0. I means till this is greater than or equal to 0, it is remain inside this region. For this, all this function where the t is between or belongs to the boundary of -3 to 0, we can have this scenario which has been shown in the figure. Now after then when the t minus 3 is crosses the -3, then we can have a new scenario. So we are going to that portion. What happens? Then we comes to the region number 3, and region number 3 is the region when the t is larger than t. I mean, equal we have already considered, so we considered it is t is larger than 0. Then what happens? That we again take a look of this two signal. Uh, yeah, we take the signal and we just copy paste it. Right, we just copy paste it over here. Okay, this is a signal, and then another signal what we have is this one. We just copy paste it. Okay, so that is our h of t minus. Now what happens if we consider this portion is only this portion, with the amplitude 2, with the amplitude 2, and here we paste here. Then what happens? The second end will goes inside, right? The second end will goes inside, and then you can have this scenario where the t is larger than 0. So what happens at this point is again t, this point is t minus 3. And what are the overlapping area? So overlapping area we may consider as this portion whole. This whole portion has your overlapping area. So in that case, what is the lower boundary? So lower boundary is t. This sorry, upper boundary is t, and lower boundary is t minus 3. I mean, so the shaded region or overlapping region is bounded by this 2 point t minus 3 and t, where t minus 3 work as a lower boundary and t work as a upper boundary. So in this case, if we find y of t, so y of t is basically bounded by this point t minus 3 and t, and here x of tau and h of t minus tau will be bounded. This point is 2, right? This amplitude is 2 and this amplitude is 1. This amplitude is 1. This is 1. This is wrong. And with respect to d tau, so this is h of t minus tau signal. That is we can say it is t minus 3 to t, and here we have a 2 1 d tau. And if we solve further, then we can have a 2 tau, and this limits are applicable to t minus 3 to t. So that is apply the limits 2t minus 2 t minus 3. And if you solve this, then 2t minus 2t plus 6. So 2t will be cancelled, and we have a 6. So y of t is equal to a 6 in this region. y of t is equal to 6 in this region. So if the y of t is equal to 6, then it is a constant. It doesn't depends on any value of t. It is constant. It is a constant line, which is at any value of t, it is a constant line. Okay, but how much time this region will bounded by 0 lower boundary? But what is the upper boundary? I mean, at what value of t this scenario is exist? So when either the t minus 3 will not cross the 3 or t will not cross the 3. So obviously the second instant comes, I mean first instant come first is that t will cross this 3, right? So till t is not crossing the 3, it means till the both the ends of h t minus tau will remain inside x of tau function in overlapping, then we can have this scenario, right? Okay, now consider the second portion of this one. Then we have, sorry, we again take these two signals so you can have a more better idea. Okay, so we take this one as a x of tau. This signal we will choose as a h of t minus tau, and if we are going to find the overlapping region in this case, so we will just hold only this function and we put here. Okay, so this is the case, right? This is the case where this one the upper part, or this part of h of t minus tau is outside of this boundary, right? It is outside of this boundary, but this lower end, the lower end is still inside. So this is the t minus 3, and if you find this shaded region, so shaded region is bounded by the 2 point, this point 3 and the second point is t minus 3. So if you find here the y of t, so that is bounded by this two region. This lower bound is t minus 3 and upper bound is 3, and we have x of tau and h of t minus tau d tau. And what this region is, in this region what we consider, we have considered where this is applicable only till t is larger than 3, right? T is larger than 3, and the second part we will discuss later on. So here it is t minus 3 to 3, x of tau is 1 in this region, h of t minus tau is 2 in this region, and with respect to d tau. So here if we give this limit 2 tau, t minus 3 is lower bound and 3 is upper bound, and if we solve this, so it is 2 into 3 minus 2 time of t minus 3. Students can put their microphone in a mute position. So 3 into 2 is a 6 minus 2t plus 6. So that is equivalent to 12 minus 2t, right? This y of t. And till the second end will not cross this point 3, then we can have a same scenario. I mean, till t minus 3 is less than or equal to minus 3. I mean, is equal to t less than or equal to 3 will shift this side, right? So what happens is sorry, I think sorry, plus 3, so is equal to 6. So till t is bounded between 3 to 6, we can have this scenario, right? This is the reason number 4. Now if you consider the next reason, so next reason what happens, this t minus 3 in this region number 5, uh, what happens, this x of tau is minus 3 to 3, but then h of t minus tau will cross this boundary, right? Cross this boundary, maybe somewhere here where the t is larger than 3 or 6, sorry, t is larger than 6 means shifting amount is larger than 6. Actually we have started from minus 3, that's why it takes a 6. Minus 3 to 6 is equal to 3, right? So that's why, so that is h of t minus tau is 2, but here there is no overlapping. So if there is no overlapping, we can say that our signal y of t is equal to 0. Why there is 0? Because we don't have any overlapping over here, and then we stop over here. So because after this every value of t which is larger than 6, we have no any overlapping region. So now let's summarize the things what we have cover today. So this I mean in this example, so we can say y of t is equal to 0. The first part we have taken where y of t is equal to 0 when the t is where, sorry, it's n, not n, t is less than -3. Okay, so t is less than -3. Then the value of y of t is equal to something like as a 2t plus 3, 2t plus 6, we can say 2t plus 6 when the t does lies between -3 to 0. Then we have a constant value, and this constant value is equal to uh, we have a constant value is equal to 6 when the t uh, is between 3 to 6, right? I mean, sorry, 0 to 3. And we can have the value of 12, this 12 minus 2t, right? 12 minus 2t, where the t is between the 3 to 6, 3 to 6, and is equal to 0 elsewhere. Now we plot this graph. So how this graph will looks like. We plot this graph over here so you can have idea. Okay, so then we will plot this graph. This graph is basically start from -3, right? We can have to think that this is actually starting from -3. So somewhere here we have a -3 because it start from -3 to up to 6, right? In between we have a region of -3 to 0, and then from 0 to 3. So from -3 to 0, we will before -3 it doesn't exist. Y of t would be a 0. So there is no need there is no need to draw the signal. But from -3 to 0, the signal is 2t plus 6, right? 2t plus 6. I means if we take the 0, t is equal to 0, right? We have a 2 points, so we put both the points and we'll find the two dots. So first we take the t is equal to 3 -3, so -3 into 2 6, I mean 0, right? That is the 0 point. And if we put the t is equal to 0 here, then it is 6. So it is somewhere here at this 0. At this 0 we have a 6 value. And if we join down this line, so we can say there may be a drift signal. Okay, now after this what happens? After this again we will consider this between 0 to 3. I mean between 0 to 3 it is a constant value of 6. So this constant line which we can draw is a constant line irrespective of the time up to here, right? This is the signal. And from 3 to 6, and from 3 to 6 it is 12 minus 2t. So for that one what we can do, we can put t is equal to 3 and t is equal to 6 alternatively in this equation, 12 minus 2t. So first we put t is equal to 3. So if you put t is equal to 3, so 3 into 2 6, 12 minus 6 6, that is already this point. But next point is when we put 6, so it is 6 into 12, 12 minus 12, 0, it means 0, right? So that is the line which is connecting this two dot, right? And this is what the trapezoid waveform of y of t, right? It is a similar examples what we have covered last time. Now the next example it bit difficult, but I would like mostly to give you on a homework. You can solve by yourself, and whenever we meet next time by tomorrow, then we will give more focus on this one, because it takes too much time, and we are generally during the online lecture it is instructed to engage the students for 40 to 45 minutes. This time will this takes 20 to 25 minutes to solve this example. So we are not going to solve. We basically solve in the next lecture. But today I just give you a hint how the signals is basically how this examples can be calculated. So in this example, it is given there are two signals, and one signal is a triangular signal, and another signal is a square wave signal. So we can say there are two kind of a signals does exist. This one signal is or triangular signal like this. Okay, and from here, this is one signal, and this signal is considered as a x of t signal. This signal is considered as x of t signal. This is 0 point. This is the this point is basically point 2, and this is the point 4. The function is not given. Uh, Maybe a town. If you consider it's a town. But function is not given. How to this calculate this? And only this is given, and that the maximum value which it holds is a 2. And the another signal which is given is h of a town. And in that one, this is given that we can have the signal, and this one will hold. So that is the 2, that is 2, that is 0, and that is. So if you observe the signal x of tau and h of tau, uh, this h of tau we can easily define, right? This h of tau we can easily define. This function is basically the 2 for all this value of tau between 0 to 2, and it is 0 elsewhere, right? So it is constant value, and such kind of examples we already considered earlier. But for this triangular, how to define this? So you see there are two functions. The first function, if you see the signal, you can see this is the positive going ramp, and this is the negative going ramp, right? So how you define the signal? So first we discuss about this portion, how to define this portion. So for this portion we have a one function, and for this portion, another portion, we have a different function. This portion we have a different function. So if we talk about this function, the first function, this which is positive going ramp, we can say this is starting from 0. So how we define this? We can define this is the starting point 0 plus slope multiplied by t. This is way how you define this. So what is the slope? Slope is y1 minus y2 by x1 minus x2. So at this point where we can have a x2 and y2 value, and this is the point where we can have a x1 and y1 value, right? So you see x1 and y1 both are 0 0, both this is 0, this is 0, but for this function x2 is a 2, right? X-axis value, and y-axis value is also a 2, so this is 2. So if you find the slope, so slope is basically y2 minus y1 divided by x2 minus x1 plus starting point plus slope into t. So both are that we can say this is the first function of this one, and we can say f1s function, right? F1 of t function. So that is a 0, and this y2 minus y1 means a 2 minus y2 means a 2, and y1 means a 0, and same for x2 minus x1 0 into 2. So this 2 minus 0 is 2, divided by 2 minus 0 is 2. 2 will be cancelled out, and we can have only the slope of t. But here we are not using t, we are using the tau as a domain. So rather than t, we are using the tau as a domain. So that is we replace with the tau everywhere, right? So this is the tau, this is the tau. So this is tau, and here we tau. So this is the tau. So that we have found out for positive going slope, and that is this one is the tau. So this slope is tau. Now we going the negative going slope, but negative going slope is starting from which point? What is the value here? Y-axis value 2. So if you go with this one, so this function for this one is f2 of t is equal to the starting point. I mean starting point in vertical movement. Starting point means not on x-axis. The starting point. I mean so y point plus slope into t plus slope into t down. Sorry. So what is the starting point here? The starting point is 2. So that we can say is that 2 is a starting point. The slope is now what happens is x to x3, and this we have to consider x3 y3. and x3 and y3 means both are x3 means 4 and y3 means 0, right? So we consider this. So now we can find y3 minus sorry, let's use the green color. Y3 minus y2 divided by x3 minus x2 multiplied by tau. So that is 2. What is the y3 and y2? So y3 is somewhere y0 and y2 is 2. So it is now 2 minus 0 minus 2. Sorry. So that is 0 minus 2. And what is x3 and x2? This x2 is somehow 2 and x3 is a 4. So that is 4 minus 2. So that is 4 minus 2, right? Multiply with the term. So if you solve this 2, this is the minus 2 divided by 2 into term. So it will be cancelled out, that left with only term. So that is 2 minus term. So the slope of this one is this sorry, function of this one is the 2 minus tau. So we have a two functions over here, and that's why this example becomes a complex, because sometimes whenever we start to move h of tau inside x of tau, then at some moments whenever it collaborating with the anywhere between 0 to 2, you can consider the function as a tau. And whenever the portions maybe sometimes it happens that half of the portions or half of the portions will fall in this region, which let me go with the tau function between 0 to 2, and another half will fall between 2 to 4. So it maybe goes with this function 2 minus tau, right? So the integration is basically divided in two part for the portion which lies between 0 to 2, and for the portion of a square wave of h of tau function, h of t minus tau function, which lies between 2 to 4, then it goes with the different function, right? So that way you have to identify and you have to solve this example. So it is left for your examples. Again, we can check whether this 2 minus tau function is right or wrong. So at a point number 2, this function is not right? I think the starting point we have not considered. uh, 1 minute. I think there might be some issue because yeah, sorry, yeah, this is okay. This slope into is actually starting from point 2, right? X-axis point 2. So this we have to multiply not with tau, it is tau minus 2. Sorry. So that is tau minus 2. So that is tau minus 2, because if the signal is shifted at the point 2, m signal is not starting from t, it is shifted starting from 2. So it means it is shifted by 2. So rather than t, we use the t minus tau. Here it is tau, so we use the tau minus 2. So that's tau minus 2, sorry. And then again we go with this one. Then we can write here, this is the minus tau, minus minus plus, this minus is minus, and here it makes the plus. So it is a plus 2. So this function is 4 minus tau. Sorry. So now here we need to use this function as a 4 minus tau. Okay, now we need to recheck this. So at point number 2, if we check, we put the value of tau is equal to 2. We are getting the amplitude value of 2. This one, it is fine. And at the, if we put the value of tau is equal to 4 here at this point, then we are getting the amplitude is 0. That is also right. So it is 4 minus tau is a function. Now it is left for your exercise. This is given. So now I remove this portion. Only the x of tau is given and h of tau is given like that way. And now you need to find the convolution between these two signals. So that is the exercise for today. And now we conclude the session over here. Find the convolution, right, between these two signals. Now we will meet after interval in the by tomorrow. And I hope till that you solve this example. And if not, we will even solve this one in the next exam, next lecture by tomorrow. Now I would like to take your presence. So I will take your presence number. So 1 to 5, if anybody is present, so they will pronounce their whole number between 1 to 5. Hello. Okay, nobody is present. So between 6 to 10.
Number 6 present.
6 is present, 7 is present, right?
9,
9 is present. Okay.
10,
10 is present. Good. 11 to 20, 11 to 15. Okay, so nobody is present between 11 to 15. 16 to 20, anybody is present here?
17.
17. Okay. 10. 17, then okay, 21, 19. 21 to 25,
22.
22. Then 20 up to 25, anybody is present? No. 26 to 10,
28,
28. Okay. 28. Then 31 to 40, anybody is present?
35,
35,
38.
33,
38, 33, and okay, then 41 to 45, anybody is present?
42,
43.
42, 43, then 45 onwards, 45 to 55.
46,
47.
Okay.
46,
49.
49. Then 49 onwards,
50.
50, 51 to
52,
52, then 55,
56.
56,
57,
51,
57,
57. Okay. 57. Then anybody else? Okay.
D2D4,
D2D4, 8 number. 8, right? 4 and 8.
18, 7, 8.
Okay, so only D2D is only 4 is present. Here it is 18. Okay, so you see the number 6, 7, 9, 10, 17, 18, 19, 22, 28, 35, 30, 38, 33, 42, 43, 46, 7, 49, 50, 52, 56, 57, and D2D4. Okay, so now we conclude this session over here and have a good time. Good day. Goodbye.
'Thank you, sir.
23 present.